everyone, welcome. I hope that you're starting to get a handle of these rules of inference. And you don't have to worry about these fancy names here. Just make sure you're familiar with which rules of inference hold and how we can apply them. And I think they're, for the most part, common sense. Some of them are a little bit unexpected, but if you go and prove the corresponding tautology, then it's not so bad. So make sure you feel good about the rules of inference that don't have any quantifiers or predicates, and then also rules of inference with predicates and quantifiers. So I'll post these notes so that you'll be able to review those two tables. So I wanted to talk through a few of these verbal premises and conclusions to better understand how we can connect between these symbolic rules of inference that were given to these statements that were given in English that we can sort of understand and visualize. And so it'd be a good exercise for you just to try to read through these premises. If I play hockey, then I am sore the next day. If I use the whirlpool if I'm sore, I did not use the whirlpool. Try to just read through those and disregard the rules of inference for a little bit and try to see if you can piece together some conclusions from those premises. But what I'm going to do, what makes most sense to me, is to introduce propositions and rewrite these three premises symbolically, so then I can better relate them to these rules of inference that I know I have to deal with. So whatever's easiest, but somehow you have to justify your work and your conclusions. So if you see on one of these, I posted the solutions that are in the solutions manual, so you can kind of see how you might go about talking through any conclusion that you'll make. But I'm going to do it all symbolically and also with, some written justification so that you can understand what I'm doing here. So I'm going to start with introducing propositions that I'll use. So the first proposition, the first statement I see is I play hockey, and sometimes it helps if you use a corresponding kind of variable. So I'm going to say the proposition H means I play hockey. Okay. And then the next statement that I see, so I've done this one, but notice it's connected with an if-then, so I only want to build propositions that have no connectives. So I am sore the next day. So I'm going to say S, sore. Or I think I need a little bit more there. I don't really like this next day thing, so I'm just going to cross it out. So S, I am sore. And then the next thing I see is I use the whirlpool. So I'm going to say W is the proposition I use the whirlpool. And then our last statement, notice, just uses W, so I don't need to introduce a new proposition. So now let's go piece by piece here and try to understand how we can represent this symbolically, okay? So if I play hockey, H implies then I am sore, S. If, okay, now careful, you've got to make sure to read this in the appropriate order. I use the whirlpool if I am sore. This is saying if I am sore, then I use the whirlpool. So make sure that you're familiar with those different ways of representing conditional statements, okay? So this actually means sore implies whirlpool. And that makes more sense, right? You wouldn't use the whirlpool then be sore, right? This makes more sense. And then our last one is just the negation of whirlpool. So sometimes when you're completing problems like this, you're given premises and conclusions. But in this particular exercise, we're trying to start with the premises and figure out what valid conclusions we can make. So anytime you see the word premises, you should assume that those are true. Because the form of an argument, for example, with these, let's just write down this argument here. P P implies Q. So these first two statements are my premises. So these are my premises, and we would assume that these are true to have any sort of argument, because based off the information these are true, we're saying our conclusion is valid and true also. So what this argument is saying is, given that these premises are true, I can conclude Q. And so to check these arguments, what you're going to do is join all your premises with and then show that them implying Q is a tautology is always true. So you can do that with a truth table or with just a series of logical equivalences, and that should make sense. And you'll have practice, and I'll do a couple of those later videos. But for now, I just want to kind of take these rules of inference for granted and apply them here. So let's see what we've got going on here. What's important to remember is that if you've got a true statement, so those two statements are true, we can write any logically equivalent statement instead of. So it's nice to kind of play around with logically equivalent statements. So I know that these premises are the same because the contrapositive is logically equivalent to the conditional statement. So you notice the contrapositive of H implies S, so hypothesis implies conclusion is negation of conclusion implies negation of hypothesis. And same story with S implies W. The contrapositive of this, which is logically equivalent, is negation of W implies negation of S. And the reason I wanted to do this is because when you have one lonely proposition, you want to somehow connect it to your other premises. And as it stands, I don't see a not W in my other premises, I only see a W. So if I can somehow write something with a not W, that would be helpful. And now hopefully you can see how these all will flow together. Because remember, if I've got P implies Q and Q implies R, I can connect this hypothesis with this conclusion, okay? So let me write this one down so that you can see what I'm talking about here. So I'm going to write down this rule of inference here. So if I've got P implies Q and Q implies R, if those are true premises, then I'm able to conclude that P implies R. So what I'm going to do first, before I throw in this not W, is I'm just going to use these two true premises to try to make a conclusion using this rule of inference. So what I'm going to do, I'm just going to start by writing those premises. So not soar implies not play hockey, and let me write this one first, okay, you'll see it better. And then not whirlpool implies not soar. And from this rule of inference in red here, I know that I can conclude that not whirlpool implies not hockey. So if I did not sit in the whirlpool, then I did not play hockey. Okay, so this is one valid conclusion that we can make. But now the reason we were introducing those negations was to combine that not W. So now I'm going to take an implication and combine it with a hypothesis that's true. So that's just this rule of inference here. So let me write that one down here. So I'll write it in red to stay consistent here with my rules of inference being used. So P implies Q. If I know P is true, then I can conclude that Q is true. So using that one here, I'm going to write not W implies not H and not W. So therefore I can conclude not H. So my conclusions here include not playing hockey, right? If I combine all of these three premises at once, I would say because of these rules of inference, I can conclude that I did not play hockey. I can also conclude And remember, I can conclude anything that's logically equivalent to my conclusion. So notice that the contrapositive is if I play hockey, then I will sit in the whirlpool, which makes sense. Okay? So these are some conclusions that we can make based off of the given premises. Okay? And if you want to write them symbolically, these would be suitable. Okay? And you'd want to justify any conclusions that you're making with the rules of inference use. And like I said, you don't have to know or memorize those fancy kind of Latin terms. Just understand how it works symbolically and how to write it out symbolically. Okay? Let's look at one more example like this to wrap our heads around trying to use rules of inference with statements that we're making. Okay, so now I see this all, and that makes me think of a quantifier, whereas in the last statement we didn't really have any quantifiers that were being used. It was just statements that weren't dependent on some day or some quantity. So we're going to have to think about rules of inference for quantified statements. So keep this table in mind and kind of open up while we're talking about this. But so it looks like I have some statement that something is an insect, some statement that something has 6 legs, some statement that a dragonfly is an insect, and statement that spiders do not have 6 legs. So it looks like predicates that would make sense here would be having 6 legs and being an insect, because both of these other statements also involve those 2 predicates. So I'm going to go ahead and introduce those predicates. So I'm going to say let X be all, I'll just say living creatures, okay? You could structure the domain a little bit different here, and that would kind of change the problem, but I'm going to keep it broad so that we don't get confused. And I'm going to say let I of X be X is an insect. And then insect. And then I'm going to let, let's say legs, I'm going to say L of X so then I don't get confused with spiders. Let L of X be X has 6 legs. Okay, so now if I want to write out this first statement, all insects have 6 legs, symbolically, I'm going to use the universal quantifier for all X, for all living creatures. If insects, then 6 legs. Okay, and then dragonflies are insects. That just is I of dragonflies. And spiders do not have 6 legs. That would be negation of, oops, I meant to have L here, right? L of X. Negation of L of X. Okay, so now let's see how we can piece this together to try to make some conclusion here. And so if you notice, this statement is saying it's true for all X. So I already know that I can conclude something here with these first 2 premises. So if I look at rules of inference for quantitative, so if I know something's true for all elements in my domain, then I can conclude it's true for a specific element, okay? So I'm using a combination of this universal thing, and then also I'm using this rule of inference, okay? So let me show you what I'm talking about here on the first one. So I'm just going to focus on these first 2 premises to try to conclude something about dragonflies. So I'm using for all creatures, if an insect then has 6 legs. And then I know that a a dragonfly is an insect. So because of, let me use a different color here, because of this rule of inference for universal quantifiers, I can conclude P of C, okay? Where C is our, let me see if I'm writing this. Yeah, where C is in the domain of X. Okay. So then, using that idea, if I'm saying that this statement, this implication must be true for any value in our domain, then this must allow me to conclude that L of dragonfly. So I must be able to conclude that dragonflies have 6 legs. Okay, so this is my first conclusion. Dragonflies has 6 legs. Dragonflies have 6 legs. Okay, now let's look at another one and see what we can do. I know that this was L of spiders. Now, I want to conclude something that has the negation of L of X. So remember, I can write any equivalent statement that is related to my true premises. So an equivalent statement would be the contrapositive. So since the contrapositive is true, I can use a similar argument here and say negation L of spiders. So this is true for a specific element, and that allows me to conclude that it's not true that spiders are an insect. Okay, so spiders are not insects. And we're just using the same argument here, and also we're using P implies Q, P therefore Q for both of these previous arguments. Okay, spiders are not insects. And I think that's really about all we can conclude here. If you see anything else, let me know, or if you have questions about what we did. So make sure you're clear symbolically what you're doing and what your justifications are, and make sure your conclusions are clearly written so that they're easy to interpret. And again, I'll post these solutions so you can kind of read through. I did omit some pieces of B and C. I omitted B because you can't really conclude anything, but and I omitted a statement from C, so you can kind of read through what they say about that. But hopefully that helps a little bit. Next, I'm going to go through some arguments and helping you determine if they're true or false, and these will be really similar to the homework problems. And then I'm going to go through and verify whether or not an argument is valid or not. Okay, so I will talk with you soon.